Good morning, dear student. I am Dr. Aijaz Khan, and today I am going to start a new chapter, electrostatic potential energy and electrostatic potential. So let's start. So, good morning, student. I am Dr. Aijaz Khan, and today we will start electrostatic potential energy and electrostatic potential. So the contents for today's lecture are as follows. First of all, we will define electrostatic potential energy between 2 points A and B, and then we will derive also the expression for electrostatic potential energy. Then we will define also electrostatic potential energy at any point due to electric field. Then again we will define difference in electric potential between point A and B in electric field, and then electric potential at any point in electric field. Then we will also derive the expression for electric potential due to point charge, then due to group of point charge, then due to electric dipole, and then we will also try to find out the relationship between electric field intensity and potential. And finally, we will see what are the dielectrics and what is the polarization phenomena. So let's start. What is electric potential energy? So two very important things before starting this topic, which is very important. The first thing is, in physics, potential energy is not defined, but difference in potential energy is defined. So this is very important point. In physics, there is no proof that in any book potential energy is defined. Potential energy is not at all defined in any book. Difference in potential energy is defined. And the second thing is that difference in potential energy is defined for system of charge. This is very important, because say for example there is one charge q. This is the charge q plus charge q, and suppose if I want to find the potential, electrostatic potential, electric potential at this point P, which is r distance apart from here, then the potential here is 0. So this is very important, because potential is defined for system of charge. At least two charges must be there, and there is only one charge. There is no charge here. So if I try to find out the potential here at this point, I cannot find the potential. So these two things, before starting this chapter, we must keep in our mind. The first is, potential energy is not defined, but difference in potential energy is defined. And the second thing is, difference in potential energy is defined for system of charge. That means at least two charges must be there in order to get the potential. You cannot find the potential due to single charge. So this is the two things which we must keep in our mind. So what is the definition of electrostatic potential energy? So the difference in electric potential energy the difference in electric potential energy between any two points A and B in the electric field of source charge Q is the work done in moving a test charge from point A to point B without acceleration. Or in a mathematical way we can write UB, that is the potential energy at point B, minus UA, that is the potential energy at point A, that is equal to the work done by either external force or by conservative force, negative of the work done by conservative force or work done by the external force. These two things we should know. The difference in electrostatic potential energy between any two points A and B in the electric field of source charge Q. Say for example this is charge Q, and suppose there are 2 points. These are the point A and this is point B. Say for example, suppose this is here. I have placed charge plus Q charge, and there is a point B, and here is the point A. So the the potential energy at B, which is given by UB, and the electrostatic potential energy at A, that is UA. The difference between these two, that is UB minus UA, is equal to amount of work done to bring a test charge Q naught from A to B, and it is independent of the path we follow, whether we take from A to B in this path or in this path or in this path or in this path also. You can take any path, it is path independent, because electrostatic force is a conservative force. So again I repeat the definition: difference in electric potential energy between any two point A and B in the electric field of source charge Q, that is the source charge which produce electric field, is the work done in moving a test charge from point A to point B. Suppose here at point A the charge Q is placed, and if I want to move it from A to B, then I have to do some work against the electrostatic force which is acting in this direction if the charge Q is also positive. So in that case the work done in moving charge from A to B is equal to the difference in the potential energy between these 2 points.